Hi science students, welcome back. Today we're going to be focused on calculating potential and kinetic energy. Potential energy can be represented using the acronym GPE, and kinetic energy can be used KE as its acronym. We're going to be using both of those as we work out our word problems for today. You should have already written down the learning target onto the top of your notebook page for today. If you haven't done so, make sure that you pause the video to write it down. It says, I can identify graphical models and mathematical equations describing potential and kinetic energy. We're going to focus on mathematical equations as our representatives of potential and kinetic energy today. We practiced with those graphical models yesterday. Right below where you have your learning target, I'm going to want you to write down the formulas. I put each of the parts of the formula in a different color to make it easy to distinguish them from one another. So our kinetic energy, or our KE, its formula is going to be 1/2 multiplied by the mass multiplied by the velocity, or the speed, squared. This can also be abbreviated down as KE equals 1/2 mv squared. Gravitational potential energy, or GPE, is going to be the mass times the gravity times the height. This can be abbreviated down as GPE equals mgh. The reason that these formulas are not the same is because what impacts that type of energy is different. We know that kinetic energy is representative of motion, things that are moving or things that are using energy in a motion-like state. We know that gravitational potential energy has to do with position or stored energy. So where it's sitting or how it's been stretched, those are going to be things that impact our potential energy, not our kinetic energy. So our formulas are going to be different, and we need to know which one is being asked before we can really move forward with putting in our word problem. If you need to pause the video here to write this information into your notebook page, please do so. All right, so we're going to go ahead and move forward. I'm going to move our learning target off to the side, and I'm going to scoot our formulas up. Our first example is going to be this one. You serve a volleyball with a mass of 2.1 kilograms. The ball leaves your hand with a speed of 30 meters per second. The ball has this kind of energy. So I know I first need to decide, is it kinetic or is it potential energy before I can move forward? It's asking me that on this line. Go ahead and pause the video to write the word problem down into your notebook page. Let's go ahead and decide, is this kinetic or is this potential? When I read the word problem, I see that they're serving a volleyball, which means they're hitting a volleyball with their hand so that the volleyball flies over the net. I see that the ball is leaving my hand, it has a speed, it's moving. So I know that if it's moving, it has to be kinetic energy. I'm going to write that onto this line here, kinetic energy. And I know that if it is kinetic energy, I should be able to find these pieces of information to plug into my word problem. So first, every time I do a word problem, I want to write out the formula first. So I've got KE equals 1/2 times mass times velocity squared. And notice that I'm trying to write this in different colors, but that's really just to assist you in seeing the similarity between the formula that I've given you. You can do it in different colors if you'd like to, but that's not a requirement. I can also write this abbreviated down. So I have my full length formula, but I could also have the same formula in my abbreviated form. 1/2 mass times velocity squared. And it's really important to remember that squared. A lot of times students will forget that they have to square this number, and they'll have done the rest of the word problem correctly, but they'll get the answer wrong because they forgot to include this squared. So let's go ahead and start plugging in our information. So I know that I need to first put this 1/2 in the front, 1/2, and I need to look for my mass. So I'm going to look back through here, and the first sentence says you serve a volleyball with a mass of 2.1 kilograms. So I know that that must be my mass, 2.1 kilograms. It says that right there in the word problem. It tells me this is the mass. So I'm going to say 2.1, and you want to include the unit of measurement, so 2.1 kilograms. So now I need to look for my velocity. Velocity sometimes will be written as speed, sometimes written as velocity, sometimes written as moving at the speed of. All of those are the same, velocity. So I'm looking for my speed, and it says it right here. It has a speed of 30 meters per second. So I'm going to write 30 meters per second and squared. It's really important to remember that piece. So now I need to work out the math. So I'm going to write KE equals 1/2 1 kilograms, and I want to square this number here, this 30. So when I square 30, I get 900. So then I can just multiply these three by each other. So let me scoot this up. I'm going to put my calculator right here so you can see it. So I'm going to say 900 times 2.1 equals 1890 times 0.5 equals 945. So my kinetic energy equals 945 joules, which can also just be written as a J. Pause the video if you need to in order to copy down the steps that I have here. When I'm going through and I'm looking at your graded work, I'm going to be looking that you've written down the formula, you've written out what the different numerical values for each piece of the formula are, and that you've written out the units of measurement. So it's important to include my units of measurement both for mass and for velocity and for my energy in general. So pause the video here if you need to do so before we move on to the next example. So let's move on to our second example. Our second example is this one. A baby carriage is sitting at the top of a hill that is 21 meters high. The carriage with the baby weighs 12 newtons. The carriage has this kind of energy. Pause the video here to record this second example before we move on. So let's break this question down. This says that the baby carriage is sitting at the top of the hill. It doesn't imply any motion. It doesn't say it's rolling or it's moving in any way. So we're going to assume that this is potential energy. We know that gravitational potential energy, GPE, this formula we see here, has to do with its position, where it's located. So I want to first write out my formula. So GPE equals mass times gravity times height. I know that that can be abbreviated to GPE equals mgh. And I can write either one as long as I'm writing out the entire formula before beginning the word problem. So let's find the pieces of information that we need. So in this first sentence, I see a baby carriage is sitting at the top of the hill that is 21 meters high. I know that this M does not mean mass. This M stands for meters, a unit of measurement. So I know that that is not going to be my mass. Let's keep looking. The carriage with the baby weighs 12 newtons. So this word problem is trying to trip you up. It's a little bit tricky, and you have to consider, what does it mean, the difference between weight and mass? So when it's using this word, weighs, your weight has already factored in the gravity on the planet you are on. So if it says that the carriage weighs 12 newtons, this means that it includes both the mass and the gravity. Those have both already been multiplied together. That's what the weight is. If this said that the carriage with the baby has a mass of 12 grams, we would write in mass first and then fill in gravity. But because it says this word weighs, it means both of these have already been included. So what I should put on my paper is GP equals 12 newtons, which will check off my mass and my gravity. Your weight is your mass times gravity on the planet that you are on. So now all I'm looking for is height. I can go back up here to my 21 meters high, and I can plug this in, 21 meters. All I need to do now is multiply these two by each other. So let's do that. Here's my calculator. 12 times 21 equals 252. So my gravitational potential energy in this scenario is going to be 252 joules of energy. We're going to do one more example, but go ahead and pause the video if you need to in order to copy down any steps that you missed. Let's complete our last example. So example number 3 says a cinder block is sitting on a platform 20 meters high. It has a mass of 24 kilograms. The block has this kind of energy. Go ahead and pause the video here to write down the word problem. All right, the block has potential energy because there is no movement implied. A cinder block is sitting on a platform. It is just sitting there. It's not moving at all. So I know that my GPE is going to be mass times gravity times height. So I need to go looking for these pieces of information. So GPE is going to be mass first. Let me find that. A cinder block is sitting on a platform of 20 meters high. I know that's not a mass. It has a mass of 24 kilograms. So I want to put that in, 24 kilograms. Notice that it does not say it has a weight of 24 newtons. This is giving me the mass. If it's only giving me the mass, I know I need to include gravity. Gravity is always going to be 9.8 meters per second squared. This squared is part of the unit of measurement. So we know that we're not going to need to square this whole number. 9.8 meters per second squared is the unit. Lastly, I need to find the height. It says it's 20 meters high, so I'm going to put 20 meters here. All I need to do now is multiply these numbers, 24, 9.8, and 20 together to figure out what my gravitational potential energy in this scenario is. So let's do that. 24 times 9.8 times 20 equals 4,704. So I'm going to write 4,704 joules as my answer. You should be able to use these three examples to assist you in completing all other word problems we will look at. Have a really great day, and I'll see you soon. Bye-bye.